Hi again. So I want to wrap up Impulse with a little discussion of the graphical approach to doing impulse problems. So I'm going to refer back to the example that we're looking at before. You had the foot pushing on the ball for a certain period of time, and the impulse was the force times the time. So, okay, keeping this in mind, let's go now and take a look at this. So let's make a graph, right, of the force that the foot is delivering to pushing with on the ball as a function of time. So this part right here, it's not pushing. So, and then the foot makes contact with the ball. Now the force is being delivered from point 0.03 to point 0.05. It's being delivered to the ball. There's a push happening. And then after that, the ball has left the foot and there's no more push happening. Now, remember, we said that impulse is force times time, right? Well, force is the height of this graph, and the time is the width of this box. And so this is like the base and the height. So the area of this graph, underneath the graph here, is equal to the impulse. And so, yeah. Now, in real life, the impulse is never going to be just, suddenly it comes up and then it's constant, and then suddenly it goes away. In real life, what's going to happen is you're going to have something that gradually comes on and comes off. Now, actually, this example here, the reason it's in my notes is because in regular times, no coronavirus, we would be doing a lab where you have one cart hitting another cart, and there's these special force sensors, and this is sort of what you see. And when you would do that lab, you'd use the computer to find the area underneath a graph. So the computer would make a graph of the force as a function of time, and then the computer would figure out the area under here, and you would get the impulse. Now, the process of getting the area under a curve like this is called integration, which is a calculus thing, and the computer knows how to do that. The computer computers are really good at arithmetic. Another word for doing arithmetic is numerical operations, and so the computer has an arithmetic sort of way to carry out an integration. So we call it numerical integration. Okay, so now I did assign a lab, and in the lab you have a hockey stick hitting a hockey puck, and we make the assumption in the lab, in the analysis, we're assuming that the impulse happens sort of like this, and then this flat part here, this would then be the average force, but in real life and in reality, when you do the lab, the force being delivered is more like this. Okay, one last thing I want you to do. Please look at the textbook. Open it to page 259. Look at figure 9-2. In it, they're talking about the impulse of a bat hitting a baseball. And so you're going to see a picture that kind of like goes like that, where the bat hits the ball really hard for a very short time. Okay, so that's it. Thank you.